Good morning, everyone. Myself is Vigneshwari, Assistant Professor in the Department of Electronics and Communication Engineering from SNS College of Technology, Coimbatore. So today we are going to discuss on the topic 8086 processor interrupt. This comes under the subject microprocessor and microcontroller under the unit 8085 and 8086 microprocessor. So before moving into today's topic, let us have a quick recall about what we discussed in the previous session. So we have discussed about the instructions, how will be executed the instruction in a sequence, and sometimes even urgent event occurs and that requires immediate action. So in such situation, the processor what it does, right? So that is what today we are going to discuss about, and that mechanism we say that as an interrupt, right? So let us understand why interrupts are needed and how they have been handled in the 8086 processor. So first let us look about what is the need for 8086 processor interrupt, right? So as we said previously, consider a computer which is being connected to a keyboard, printer and various sensors, right? And these devices needs an attention at each and every moment. So without interrupt, the processor would continuously check every device to see whether the service requested has been processed, and that is process is called as a pooling. And instead it is more efficient if a student raises the hand only when the help is being needed rather than the teacher go around the classroom and ask for each and every student, right, whether they have any doubt, right? So interrupts works in the same manner. The processor it continues executing in the program normally. Whenever a device requires an attention, it sends an interrupt request signal and the processor responds immediately and it handles such request. So therefore, interrupts improve the system efficiency, reduce unnecessary checking, and ensure that important events are being handled promptly. Next, what is an interrupt, right? So let us say about what is that interrupt. So interrupt is basically a signal that temporarily executes the operation of the program and transfers the control to a specific part of the program called a special program, which is referred as an ISR, interrupt service routine. An ISR contains the instruction that is need to be handled for the interrupt. For example, if a key is being pressed on the keyboard and the processor may stop current task and execute the ISR reach the to read what the key value is and then return it to the original position. And the interrupt processing follows three steps: pass the current program, execute the interrupt service routine, and return back to the main program. And the user never notices this process because it happens extremely fast. Next comes the types of interrupt, right? So basically different types of interrupts are there that has been classified as an hardware interrupt, software interrupt, maskable, non-maskable, and there are 256 types of the software interrupt. And first let us look about what is the hardware interrupt is, right? So what is that hardware interrupt? So hardware interrupt originate from the external hardware devices, and these include examples like keyboard request, power failure signals, sensor alert, communication devices. And the 8086 provides the two hardware interrupt pins, INTR interrupt request. We say that as a maskable interrupt. The maskable means the processor can choose whether to respond or to ignore it, and this depends upon the status of the interrupt flag IF. If IS has been set to 1, interrupt are enabled, and IF is set to 0, interrupts are disabled. So while performing a critical operation, the processor may temporarily disable this INTR interrupt request. And next comes under the non-maskable interrupt. As the name suggests, it cannot be disabled by the software, but whenever NMI requires or occurs, the processor must respond immediately. Typical applications include power failure reduction and emergency shutdown, memory parity errors, and also for the critical system fault. So NMI is a fire alarm in a building. So consider it is a similar phenomenon. And regardless of what you are doing, you must react immediately. And next is that of a hardware and NMI interrupt we have been discussed. Next comes under the software interrupt, right? So basically, what is a software interrupt? So software interrupts that comes under the second category, but these are not like the hardware interrupt. These are generated by the software instructions. And the instructions used here is INT21H, and the instruction requests a predefined service from the operating system. And the 8086 supports 256 types of interrupt, right? And that is been numbered from 0 to 255. And these are widely used for input output operation, operating system service, program debugging, and error handling. Now let us see about how the interrupt are being handled, right? So interrupt handling process. So interrupt handling process that occurs in several steps. So first step, the processor completes the current execution, and the step two, it contents of the important registers like flag, code segment, and instruction pointers are being saved onto the stack and they have been executed. And the next step, it addresses the ISR from the vector table, and the next step it executes that ISR, and last step is after completing the service routine the IRET is being executed. Hence it restores the saved information and returns the control to the original program, and execution then continues exactly where it was being interrupted. So let's have a quick summary about what are the types of interrupt, what are the mechanisms, how do we handle from the vector table, and what is that ISR. So these are the references that has been used and a short quiz on the topic today discussion. So kindly watch my upcoming videos on this 8086 processor instruction set. Thank you.